Um, okay, so let's imagine a scenario. So without Git. So for those who know Git before, like imagine that you don't know, you don't know it yet, and you are collaborating on your software project within your group, several people working on it together. How can you manage it, like in a team? Like we know when we are writing an IC on a report as a team, like we can use Google Doc or share it online using like a Microsoft Doc file. What about like when we're writing codes, like when we're writing scripts? How can we work collaboratively? Yeah.
Use SVN.
Use SVN. Yeah. Any other thoughts? What can you do? Yeah. Imagine you don't know Git. What can you do? What about we share the code on Google Doc? What about when I finish my script, I share my script using a link sent to my team member, and they work on top of my script. Or what about, like another student mentioned in a previous term, like what about we save our script in a USB and then give it to a team member? So there are a lot of issues or concerns with using Google Doc for code. So this is why we introduced Git. So Git is actually a version control system. So VSN is actually short for version control system. And what is a version control system? So why do we need a version control system? The reason is because the scripts or the code like our software engineers wrote is very precious. Like we spend day and night writing our script, we do not want to lose it. Right, so we want a safe place to save our code, to save our script. And also, if we write something wrong, we want a potential to go back to clock, to go back to tomorrow or the day before tomorrow, to go back to that version, and then starting from that version. So it's a version control system. And you also want a detailed log, like what you have done for this version, what you have done for that version, what feature you worked on, like what bug you solved for that version. So you want a version control system. And programs like Dropbox or OneDrive, they can also maintain a history of files. So you can think of Git like very similar to those version control systems like Dropbox or OneDrive. But Git is specifically designed for version control for scripts for code. And Git is a program just like any others, like VS Code or GCC, so they are just a program that you can run. But because its popularity, now we actually have a GUI, like interface to use Git. But basically, it's just like any program like GCC or VS Code. It's just a program that we can run and can help us to manage the versions via central cloud. So Git is also, we can say, distributed version control system. Like you have a central place, like you can say like we store it centrally on a server somewhere. So for those who has attended your week 1 lab, so you have used GitLab. So where are those code stored? They are actually in a server in the CSE building. So your code is actually when you're working on GitLab, the remote repository, we say it's actually a server that in a building. You can think of it like a very big computer. And we can have multiple users interacting with that central cloud. And each can have a full copy of the work and also a full history of the changing log. And there are some popular platforms that use Git software, like including GitHub, Bitbucket, and GitLab. And for this course, for 1531, we'll be using GitLab. But on the fundamental part, like they are all Git software. They all use Git. And when you learn Git and when you understand how Git works, like you can quite easily transform and use other Git platforms. So this is what we are going to learn about using Git. We'll learn about version control on a single machine. So today, like how I can control my own versions on my laptop only. And we'll also learn about what if I use the lab computer sometime, but sometimes I use my laptop at home. So how I can control the different files that I change on my CSE machine or my own laptop. And we'll also learn about how we can control the versions across a team of software engineers. So when we are working on a team, how we can manage the collaboration using Git. Before we do the practical demo, so we'll do a lot of practical demos when we learn about Git. Before we do that, I want to introduce some key concepts that you will need. So this is the same figure or image that you see on the lab one, Git. So this is a very good explanation of how Git works. So remember that we say like GitLab or other Git software, they are actually a central cloud, or your file is sitting in a server in a CSE building, right? So they are remote, they are not on your laptop. However, you have also your machine, like your laptop. So there are some key concepts we will be working on today, like including working directory, staging area, local repo, and remote repo. So what are they and how we can use that? So I will explain them through a demo. So this is GitLab. So when we want to have a new project on GitLab, before we write any scripts, we can click on this button on the right-hand side called New Project. So we'll create a blank new project to play with. So create a blank project. Okay, so now we will need a project name. Who can give me a project name? Sorry? Project 1. Any others? Yeah. Untitled project. Okay. Untitled project. Okay, so this is our project name. And then we'll need to pick a group or namespace. So where we want to hold this project. So I will use my personal repo. And then we have a project Slack, and I will make it private. And normally I will initialize a repository with a README file. So what is a README file? When we create the project, so you can see a file called readme.md here. So this is also what you can see in the lab. So you will have a README file explaining what you are going to do for this lab, and you can edit that for this untitled project. Okay, so now we have created this project successfully, and it's only on the cloud. It's only on the remote server. It's not on my laptop yet. So what I can do if I want to work on my laptop, writing the code, using my VS Code, using my favorite code editor. So what I can do if I want to work locally. Remember we mentioned that the Git software is actually just a command line program, like the node and then how we run JavaScript. So we can do similar things here. So before we work on this untitled project, I need to somehow download this project on my laptop so that I can work on it, like add files, change it, add it, or whatever. So the way we do it is by clicking on the code here, and we say clone the project to my local laptop. So we say clone. Clone in Git is similar to just copy a file. So it's called clone. So I copy this URL for my, to prepare for my clone, and then open my terminal, go to the folder where I want to save this project. So now I'm on 24 T2 folder on my laptop. And what I do is I do git clone and paste what I just copied. And then you will see that cloning to untitled project. And I need my SS key. And it says done. So now when I list, you can see that there's a new project called untitled project. So it's now copied and pasted to my laptop. And when I list, I need to cd to this I love this title actually, untitled project. And there's only README file in this folder. Yeah, so now I'm working on my working directory. So working directory, you can think of it like a playground, like you can draft everything. So now I'm on my working directory. I'm not working on the remote server, like the remote cloud or on GitLab. I'm now starting to work locally on my laptop. Are you familiar with using terminal using command lines? Kind of? Yes? No? Some yes, some no, some somehow. So we don't need extensive knowledge using command line for 1531, but some basics. So for example, what if we want to have a new file in this folder? So there are multiple editors you can use, for example, VI or echo or whatever. So I'm using echo here. So I'm, hi, my name is, who wants to introduce yourself? Hey, yep. Valerie, how to spell that? V-A-L-E-R-I-E, Valerie, welcome. So I'm saving, hi, my name is Valerie, to a file called hello.txt. So now when I list all the files in this folder, you can see that in addition to README file, we now have a new file called hello.txt. And another command line like you might find useful is called VI. Like we can open this hello file and, oops, sorry. It should be txt. So now I'm opening this hello.txt file. You can see that, hi, my name is Valerie in that. Okay, so now I'm creating this new hello text file on my laptop, on my working directory. Nothing will be changed on GitLab. So the sync process will not automatically start. So it's not like OneDrive or Dropbox. So it won't automatically sync the changes. So when we refresh this repo untitled project on GitLab, you can see that there's still only one file called README. So I'm still only having this hello text on my working directory. So this is called working directory. So you can play around with it. So you are not uploading or sharing any of your scripts with your team members. And it will also, your changes will also not be applicable to your software users. So it will affect the users who are using your software. So you are working locally on your laptop only for the moment. You are not also interrupting your team members' code. So this code now only sits on your laptop. Yeah. So what do you, so now I think I got enough changes for this hello text file. What I can do to actually push this hello text file to the remote repo so that everyone in the team can have access to my change locally. So here's a command line called git I, and we can add this hello text file to a place called staging area. So we are still not pushing this hello text file to the remote repository yet. So there's something somewhere in the middle called staging area. So staging area is somewhere that you can add all the changes to. And then you can package them, like take a snapshot of all the changes and put all the changes together, make a commit, and push it to the remote repo. I will explain it. So I will do a complete process, like how we push the remote repo, and I will split the details and explain. So now, after I add it to the staging area, the next step is giving a commit. It's like giving a comment to your change. So when you want to go back, when you want to use your time machine, go back to yesterday or go back to another version, you may want to know which version you want to go back to. Right, so this is why you need a clear description of what are the changes that you made, or what bug you solve, what features you add. All right, so this is also important when you're collaborating with a group. Like your team member may also want to know what are the changes you made for. So this is why we need to leave a message here. So the message here will be add hello file. That's it. And then I can push it using git push. Now when I refresh this GitLab, you can see that there's the hello text. Let's have a break, and when we come back, I will explain to you what are the staging area, what are git add, and what git commit, and how to use them. So let's have a break and come back at 3:05. We'll continue playing with Git. So now let's come back to today's figure. So now we may have a very general, brief idea of your machine and the remote repo. Right? But how about the working directory, staging area, local repo, git add, git commit, what are they? Okay, so we'll talk about these. So, so now let's make some more changes on our working directory first. So, where's my terminal? It's here. So I'm using VI. So I'm making some more changes on my working directory now. So hi, my name is Valerie. Oh, where's Valerie? Anyone else want to introduce yourself? Hi, my name is. Hello, what's your name?
What? Ryan.
Ryan.
R-Y-A-N.
Sorry?
R-Y-A-N.
R-Y-A-N.
Yeah.
Hello, Ryan. So now I made this new change on my working directory. And it's only sitting on my working directory at the moment. So, on my hello.txt, I made a change. How I can edit that? Oh, what's going on? I want to edit my hello text. I will refresh it. Here's. Okay. So I added in my hello text. I added Ryan to my hello text. So this change is on my working directory at the moment. Right. So before we push this change to the remote repo, there are a couple of steps this change needs to go through. So we will need to first move this change. Oops. Why is it also here, and then finally here. So why do we just make the change on the working directory and then go all the way through to remote repo? Why do we need to have the steps in the middle? So staging area is the area that you put the change, like you package your changes. So now I add my change. So I will make a little bit more changes. You can see how it works. Not this one. Where's my terminal? Yes, it's here. So hello.text. Sorry, I'll add my own name. So hi, my name is Yuchao. Okay. I made 2 changes here. And Ryan added Yuchao added. I want to do something differently, actually. Sorry. Yeah. Oh my goodness. Can anyone hear me online? Okay. Can you hear me online? Yeah. Okay, I won't change that. Okay. So now I had Ryan and Yuchao to my hello text, and I add them to the staging area. Git add hello.text. So now these changes are here. And then I add one more change. I say, welcome to COMP1531. Welcome to COMP1531. Okay, so this welcome message or welcome change is still sitting in the working directory, right? And this welcome message is different from the hello message. Like hello message, for example, one feature, like I only want to add for welcome my student, like welcome everyone. And there's another feature called welcome instead of hello. Like the hello messages and welcome, so they are different features or different bugs that I solved for my project. So now I only put the hello messages on the staging area. And then I want to take a snapshot of the changes to the hello messages before I add a commit message, like saying that this is a change for hello messages. Right? So what I can do now is I can say git commit -m, and the message will be add hello messages. So now these changes are packaged, like take a snapshot of all the changes on the staging area, on the stage. So on the stage, right? So these changes are on the stage. And I take a snapshot of all the changes on the stage, like I put on the stage, and move them here. So they are now ready for push. So I commit them with a message, and now they are ready for push. Right. So when I do git push, only the changes here, like on this, like I took a snapshot, committed, add a message, so only these changes will be pushed to the remote repo. So you kind of packaged the relevant change together. So the hello change is different for the welcome change is different to my hello changes. Right? Make sense? Yeah, so this is useful when we want to take a snapshot of all the changes that you focus on solving a bug or add a feature. So you are not messing things together. All right. So now we can check on my Git repo here after my push, and I click on here. So you can see that only the changes, like including hello, my name is Ryan, hi, my name is Yuchao, is pushed to my hello text. The welcome change is not packaged, not snapshot, and not pushed to the remote repo. So these changes are separate. So this is why we needed the staging area. This is also why we need let me show you. So this is also why we need a local repo where we add a commit message. So you can see all the commit messages using git log. So when you use git log, you can see all the commit messages that we made, like including initial commit. Right? When we create the project, that is the initial commit, and then we add this hello file, and then we add some hello messages. Right? Yeah. So there are some repeating, but they are the same. And then we want to make another commit, like package another group of changes, where we only have actually the here, so the hello message. So we want to make another commit for this, welcome message. Yeah, so what I can do, so how I can commit this welcome message. Can anyone give me a hint? How I can commit this welcome change? Yeah. Yes, so git add hello dot text, right? So now, after we git add hello text, this change moved here to staging area. So now I can make more change before I commit it. Okay, hello, and then add another welcome message. Like they need to be relevant. Like when we make commits, put relevant things together and separate irrelevant changes. So I can say welcome, welcome, welcome. So they are all welcome messages, right? So imagine that I'm solving one bug or adding one feature. So this welcome, I'll put it here. So I'm still changing this hello.text. Well, welcome, welcome, and welcome. So this change is still here on my working directory. And they are relevant. So I want to pack them together, like take a snapshot of the changes together. So I can do again, git add hello.text. Now this change moved to the staging area again. So now I can take a snapshot of the welcome message. So I can say git, what is it? What should I do? Huh? Commit. -m. Can anyone give me a commit message? Welcome. Yeah, we can do that. Welcome message. Yeah. Now they are moves. So now I'm moving them together here on the local repo. So how I can add it, like push it to the remote repo? Git push. Yes, that's right. So now you can get an idea of why we have staging area, why we have local repo, and how we can make changes through the different phases. Any questions so far?
If you did a git push then and then added those two files in, would you have all three files in the remote repo, or would it just all become one file?
I will repeat the question for the online. So I made thread push for this hello text file. Will the remote repo having 3 hello text file or only 1 hello text file? Okay, so let's have a look. So what I'm going to do, I'm going to refresh here. There's only 1 hello file. Right, there's only 1 hello file. And in this hello file, all the changes have been pushed to the remote repo. So it's up to date. Yeah. Any other questions? All good so far? So you can see it's very powerful, very useful. Cool. Where is it? Where's my slides? Yeah, so I'm going back to the slides. So for setup, like how to use SSH keys, you can find the instructions on Lab 1, Git. So you can find a very detailed guideline for that. And we also demonstrate how we use Git clone. like how we clone the initial repo to our working directory, like on my laptop, and then I can work on the project. We also show git log, like a log of all the git histories, but I haven't showed git status. I will show that very soon. And we have seen git add, git commit, and git push. So now I'm going to show you git status and git diff. So what are they? Come back to here. So git status gives you a status of your repo. So what if I make some more changes to my hello file? For example, hi. And then when I run git status, it will say, I have this change to my hello.docs file, and it's not staged for commit. So it's still sitting in the working directory. So I made the change on the working directory. It hasn't been staged yet. So this is what it said, like changes are not staged for commit. So now I can, using git add, to add this hello file, so that this new change to the hello file to the staging area. And then when I run git status, it will say changes to be committed. So it's already been added to the staging area, but haven't been committed. So it shows you the status of your Git repo. And then when I use git commit -m add hi. And then when I run git status, it will say, please use git push. Nothing to commit. You can now use git push to push to the repo when you are ready. So I can use git push, pushing, and then git status, it will say up to date, nothing to commit, working tree clean. We'll explain what is working tree in our next lecture. But you can see that the change when we use git status. So it gives you an update of your status of your git repo. So it's pretty useful. Yep. What about git diff? So now let's make more changes to it, to hello.txt. And then anyone else want to introduce yourself? The last chance. Yep. Bill.
Yeah.
How to pronounce it? How to spell?
B-I-L-L.
B-A-L-L. Welcome, Bill. Okay, so now let's see git diff. So you can see that. So this is what is shown after we call git diff. So you will see very similar things when you run git diff for any to check the difference. So here there are two versions of this hello text, like A version and B version. And the difference between is that for B version, there's a new line added, which is hi, my name is Bill. So that you can check the differences that you made to your repo using git diff. Right? All good? Yeah, question.
What if you did git add, git commit,
And then
when you make git pull, will you lose all the changes?
that's a very, very good question. So the question was, what if we made a lot of changes locally, but we run a git add, git commit, but we haven't git pushed it yet, and then we git pull from the remote repo? What will happen? So let's do it. Let's do git add this hello file, and I git commit -m. The message is hello Bill, and then we run git pull. Do you want to have a look at what is currently in this hello file? What do you think is in the hello file now? Will we lose everything? No? Yes? No. So Git is very powerful and very smart. It will merge the changes to your local file, so you won't lose them. So it kind of merge. But sometimes we can't merge because maybe the same lines change. For example, hello, like hi, my name is Yuchao is changed to hi, my name is Rennie. So there will be some conflict. So we need to resolve the conflict. But we'll show you.
So if I just type git pull line into my VS Code, I won't be using it.
It depends on the changes that you made. Yeah, but run git pull regularly is a very good Git practices, especially in a teamwork, like in a team, because other people are also making changes and they are pushing their changes to the remote repo. So it's a good practice to pull regularly. Yeah. Cool. I think that is so. We've covered everything about using Git on a single machine. So now let's consider another scenario. So what if, for example, in a lab, I worked on the CSE machine. I used the GitLab. So I made some changes locally on my machine at home, and now I'm on uni at the moment, and I want to continue my work on my CSE machine. What I should do? So this like Tiger VNC or VLab. So this is like a remote machine. It's not on my laptop. So it's a remote machine somewhere in CSE. So this is just what we can see here, but it's not on my machine. So what we can do is we open the GitLab repo on a web browser. My web browser is not responding to me. Haha, what is happening to my come on. Yes, it's here. Perfect. Oh, I opened a lot. Uh-oh. Start new session. So first of all, I will need the link to my project. So this untitled project. And I can open it. Oh, sorry. Because it's on the cloud, so GitLab is like any web page that you can open. So you can open it anywhere, right? So you can open this page on your laptop. You can open it on like a CSE computer or anywhere, because it's just a web page. So you can still get the So you can still open the page on this Tiger VNC, right? So now I want to work on my CSE machine. What we can do? How can we start? Sorry? Clone it. Yes. First of all, we need to clone it. So I need to open a terminal, find somewhere that I want to like copy and paste this folder to. So I will use COMP1531 folder. And now there are two, oops, is it too small? Sorry. No. Are you able to see from the back how I can make it bigger? Bigger. Yep. And I also make this one bigger. Okay. Cool. So what I'm going to do is git clone first. So I'm getting the copy URL, copy it, cloning. Now when I list all the folders and the COMP1531, there's this new untitled project. So now this project is cloned to my CSE machine. So I can start working on this project on my CSE machine. So when I list all the files, sorry, I need to go to this untitled project first, and then list all the files. So there's the hello text, there's the readme file. All right. Now I can work on this machine. And then I made some changes to it. Can we add another file? Can anyone else give me a new file? What about a file that git commands? We can review all the git commands, and this the name is called git.txt. Okay, when I list, so there's a new file called git.txt. So I made this change on the CSE machine. I add a new file called git.txt. And this change will only be sitting on my CSE machine. It's not on the remote repo, it's not on my laptop. And then I git add this git.txt. I git commit -m. A message is a new git file. And then I git push. Okay, I pushed to the remote repo. Now I finished my work in the CSE lab on the CSE computer. Now I'm going home, and now I'm at home. And at home, I come back to my laptop. I want to continue working on this Untitled project. What should I do now? What should I do? Should I working on making more changes directly? No. So the first step is running git pull. So I need to fetch all the changes that have been made while I'm away from my laptop. Okay, so here's what you can see. Hint, you have So there's some conflicts that we need to merge. So conflicts may happen when you make a specific change to your file. So for example, when two people added the same line, and both of them are pushing to the remote repo. So in this case, a conflict will happen because, for example, I changed hi, my name is Yuchao to hi, my name is Bill. So there will be a conflict. Like Git is smart, but it's not smart enough to decide whether it should be hi, my name is Bill or hi, my name is Yuchao. So it will require your edits to the file to decide like whether it should be hi, my name is Yuchao or hi, my name is Bill. So this is one instance like a conflict that you will see. I will show it later. Another example, another case is that when we add a new file or we delete a file, and we both are pushing or pull from the machine. So in these cases, a merge conflict will happen, and you will need to resolve the conflict. Although Git is smart, but it's not smart enough to make the decisions for you. So you will still need to make such decisions. Okay, so what I'm going to do is I'm going to follow the hints provided by Git. So now, what did I do? I git pull. So I'm going to refresh this remote repo. And you can see that we do have this git.txt on the remote repo. And now we want to pull all of these changes to my laptop, like working directory. What happened? Git pull. Yeah. So it will ask you to make a commit for you to merge the conflict. So it's like a message. So I'm not changing the message by itself. So you can see now we have this git.txt on my local machine. So I pulled the change from the remote repo, and now I can work on the changes on my laptop, on my working directory. Yeah. Now I'm going to show you more conflict cases that you may need to solve. So for example, let's have a look at this git file. So I'm going to add so now we have git command. So what are the git commands that we learned today? A recap. Git add. So I'm and git commit, git clone, git push, git pull, git diff, git status, git log, git what? Oh, we didn't mention it today. So that's all we covered today. So good job. You identified all of them. So a recap of the Git commands that we learned today. And now I'm saving this file. Okay. Do you want to take another? I'm seeing people are taking photos, so I'll open this file again. Yeah, all good? Okay. Okay, cool. So I made this change on my laptop and git add git.txt git commit -m add git commands. What should I do now if I want to push it to the remote repo? Git push. Amazing. So now I've made some edits on my laptop and I pushed all my changes to the remote repo. Now I'm going to create some conflicts. So you may not want to create conflicts, but you may want to avoid conflict. But you need to know what you need to do in case some conflicts that you need to solve. So now I'm go back to my CSE machine. Before I work on my project, I forgot to git pull. I forgot. So I go directly to edit this git.txt. And now you can see that there's only this git commands here. So what I do is I delete git commands and say, Git, I love you. I love Git. So I added this line without git pull. And I'm saving it. And suddenly I realized that I forgot to git pull. And now I'm running git pull. You can see the error message saying that the request failed and blah, 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 blah. So there's something wrong because there's the conflicts that Git cannot decide for you. Like whether I should change the first line to Git, I love Git, or I should merging everything from the remote repo. So you will need to make the decisions yourself. So, I think there was something useful that normally Git give me the hints. I think it's this one. So come back, git commit pull, just do nothing. So I didn't get anything from the remote repo. What should I do now? Can anyone give me a hint? Like Git is not helping me. So I will ignore it and I will try to push. Of course I can't because there will be again a conflict. So what I'm going to do is git add this git text, git push, git commit -m. I love Git. And then I git push. Okay, rejected. Why is rejected? Because of the conflict. And it asks you to git pull first before pushing. So I followed its instruction and it says fix conflicts and then commit the result. So this is what you are going to see. So when there's a conflict that Git cannot resolve or merge for you, it will highlight the changes. So all the changes from the remote repo and also on your local repo will be put together in this file. And then you can edit this file and make it what you want. So I don't want this hide, so I can delete it. I don't want this line, but I want to keep the Git. I love Git. I also want to keep the Git commands and also the Git add commit everything. So this is what I want my Git file to be. So I edit it, save it, and then I Git add and commit and push again. And things will be fixed. So this is how you can resolve the conflicts, like the merging conflicts. So you just edit the file. Delete the lines that you don't want and keep the lines that you want. Yeah. So this is how you solve conflicts. So before I do everything else, I will check using Git status. And it says I need to Git add this new hello file. Oh, no, Git. I need to, so I merge path. So this is still not on the staging area. So I'm adding it. So Git add git.txt. And then Git commit. Git dash. I will merged conflicts. And then I can Git push. And it is successful now. I merge the conflicts and then I can make the push. Yeah. So you will see the conflicts not only when you are the single user for the project but working on a different machine, but you will also see these conflicts when you are working in a team. Like other team members are pushing changes to the remote repo, and when you pull or push to the remote repo, there may be some conflicts. And then you are using the same way to solve the conflicts. It's the same process. Yeah. Any questions so far? Online? Oh, good. Yeah. Cool. And you will do similar things for your labs. So you need to Git clone your lab to your local repository on your laptop. And after you make all the changes, and then you can Git push to the GitLab repo. And then we can see your work. So this is how you can submit your labs. Yeah. Yeah, so we mentioned Git pull and merge conflicts. And here's also a Git command summary, like a cheat sheet provided for you on the slide. We've mentioned all of them. And yeah, so this is all for Git solo usage. So we didn't manage to talk about the team usage, but I don't want to rush, like it caused a lot of confusions. So I will leave this to next Monday. So what you have learned so far will be enough for your week 1 lab. And from next week, you start to work with your team members on your project. And before that, we will talk about Git team usage. So yeah, good luck. Thank you, everyone. Thank you.